So producing a system block diagram isn't an immensely complicated task at this level. You've got a set of stages you need to go through. Step 1, decide your inputs. Step 2, decide your outputs. 3, which processing units. Draw the diagram and then set everything out in the right order. Double check that it's correct. So I'm going to ask you to write 3 system block diagrams for these 3 design briefs. So let's start by looking what our different blocks are. Input blocks, we've got a light sensor, in other words something's going to be activated by light. Temperature sensor, something's going to be activated by changes in temperature. A touch sensor and a moisture sensor. They're fairly straightforward. That's our input blocks. Our output blocks are bulbs, so that's going to give us a light. Buzzer's going to give us sound. Motor's going to give us movement. An LED, light emitting diode, that also is going to give us light. Now, in our process blocks, we've got logic gates. These are NOR gates, AND gates, NAND gates, NOT gates, etc. So they're ones where you have one, usually 2 or more inputs, and they will make a decision as to what the output should be based on the inputs. A time delay, literally something that goes, right, when I'm triggered, I am going to wait for a set period of time before I move on to the next block in the system. A latch, that's a system block where once it's triggered, it stays on until it's reset. A PIC chip or microcontroller, that has got a whole range of different things. It depends on what you program it to do. So that's going to be looking at what your inputs are, what your outputs are, and then you can program it to do any combination of things that you want. A transducer, now this is very important because a transducer basically is used to make sure that you have sufficient voltage and current to work your output block. This could be a transistor, it could be an op-amp, it could be what's called a FET, lots of different things, but basically it's a booster to make sure you've got sufficient power to actually run your output. And most circuits will need a transducer of some sort. A motor driver is a specific type of transducer that is designed to literally drive motors. Okay, so let's look at our first one. Burglar alarm system is required which activates a buzzer when light falls on a sensor. This one's fairly straightforward. The brief tells you exactly what you need for your input. It tells you exactly what you need for your output, so you've just got to decide what's going in the middle. We don't need logic gates. There's nothing about a time delay in the explanation. Possibly could have a latch, which is a form of transducer. PIC chip, no, it's just not complicated enough to want a PIC chip. No motors involved, so you've got 2 really to choose from there. One will turn the buzzer on and it'll stay on. One will cause the buzzer to only go off when there is light on the sensor, so you need to make a decision. Number 2, a system is required which switches on the motor in a fan when a room gets too warm. So you've got to choose your input, choose your output, choose your process block and fit them in. And a silent door alarm that produces a flashing light when a switch is pressed. It should be possible to change the pattern of the flash. So once again, fill in your system blocks.